Hi everyone, welcome back to chemistry. In this video, we're going to learn how to draw Lewis structures for polyatomic ions, and then we're going to get into some more complex Lewis structures. So for polyatomic ions, remember, those are atoms that are bonded together, but they have an overall charge. So drawing the Lewis structures. Oh, and before I get into this, I also meant to mention in the last video that there are other ways, other methods to go about for drawing Lewis structures. I showed you my favorite way, but there is another popular way that your book shows. In fact, your book shows step by step how to do it that way. So if you want to look at that, it starts on page 195 and goes through to 199. So if you're interested in learning that other way of doing it, I'd encourage you to look at that, or you can always, ask me and I'm happy to show you. The way that I like to do it though is the way that I explained it. And we're going to follow that same method here, just with a few extra steps because now we have polyatomic ions. So let's go ahead and do it like we always start these off. And let's say we have one nitrogen for this first one and two hydrogens. So we're just going to put the nitrogen in the middle and our hydrogens, I don't know, somewhere around there. Okay, so the next thing I like to do with all of these is I just like to populate. I've now shown which atoms I have, and now I like to populate those with electrons. So my hydrogens each have one valence electron, and my nitrogens, we're getting pretty good at this, they have 5. Okay, so now let's go ahead and, we need to remember that we have this negative charge here. Where did I get that negative charge? Why do I have a negative charge there? Yeah, I actually have an extra electron. So let's point to this and say 1 extra electron. If I had a 2 minus charge, that means I had 2 extra electrons. If I had a 3 minus charge, that means I have 3 electrons. Or in other words, I gained an electron. Yeah. And that gives it an overall negative charge. Why? Because electrons are negative, right? Okay, so we can't forget about that extra electron. So the way I like to do it is I like to just put the electron somewhere hanging out around my molecule, and that way I won't forget to put it in my Lewis structure. But it's just kind of hanging out in the ether. It's not on any of the atoms yet, because I don't know where I want to put it yet. Okay, so now I'm going to start drawing our bonds as lines, okay? So looking at this, I'm seeing that I can form a bond here and a bond here. So let's go ahead, oops. Oh yeah, that was right. And let's go ahead and erase those and replace them with a line to show that we have a bond. And remember, we didn't gain or lose any electrons there. I just am representing those 2 electrons that are being shared as a line. So we have 2 electrons right here and 2 electrons here being shared between our nitrogen and our hydrogens. Okay, so let's just do a check. So this hydrogen has those 2 electrons, so it's happy, right? It has those 2 electrons. 2 is a full valence shell for hydrogen, so we're just gonna say hydrogen's happy. This hydrogen is also happy, right? Okay, what about our nitrogen? So let's maybe choose, I don't know, green for that. Oops. What about our nitrogen? So we have those 2, those 2, that, and those 2. So how many electrons is that? So that's 2 here, 2 here, 2 here. So that's a total of 6. And then we have this lonely electron for a total of 7 around that nitrogen. So as it's written right now, that nitrogen is not happy. It does not have a full octet. And remember, it wants a full octet. It wants to be like neon, which has 8 electrons, 8 valence electrons. So what are we going to do? Well, we got lucky and we have this extra electron and we haven't put it anywhere yet. So what if I put it next to this other electron? That's allowed, right? When we have our Lewis structures, we either have bonding electrons or we have lone pairs. So I can move that electron and make a lone pair there. And so that's what I'm going to do. So let's show our extra electron in light blue, just to make sure that we are keeping track of it correctly. And now let's count the electrons around that nitrogen. So we have these two, right? These two, and these two. Yeah, that's a total of 8. So all of our atoms now, check, 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 are happy. Why was it allowed for me to put an electron there? Did it just come from nowhere? No, the only reason I was allowed to do that is because I had that negative charge on my polyatomic ion. You can't just add electrons out of nowhere. Remember the law of conservation of matter. Okay, we don't just like have an electron out of thin air. We can't create that matter, right? It has to come from somewhere. So for a normal Lewis structure, for a molecule that doesn't have a charge, you can't just put an electron in. But because we had that electron on our polyatomic ion, that's why that's allowed. So let's go ahead and just clean this up a little bit now that we've done our check and we think that's correct. And let's show our polyatomic. Now, the final step is if you were just looking at this Lewis structure, you wouldn't necessarily know just from glancing real quick at it that we have an extra electron there. It's not that clear. If you looked at it for a long time, you'd be like, oh yeah, really, that they must have like put an electron there, but it's not very quick. So the way we like to show we have a polyatomic ion is we put square brackets around the Lewis structure, and then we put the charge outside of those brackets. You could put 1 minus, or you can just put minus. It's up to you. I'll just put minus since that's how we wrote it over here. And that shows, hey, if I like look at it just real quick glance, I know, oh, there's an extra electron there. And that's a polyatomic ion. Yeah, so that's the convention. Okay, let's try this next one. So we have our nitrogen bonded to 3 oxygens, and there's a negative charge. So let's put nitrogen in the middle and oxygens around our central atom. And let's go ahead and populate our electrons. So again, nitrogen has 5 valence electrons. Oxygen has 6. So I don't know. Put it like that, I guess. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, oops, 5, and 6. Gosh, why is that coming out so weird? Hold on, sorry. There we go. Guess it's harder to draw dots than I thought. Okay, so now I have all of my electrons around my atoms. And then remember, we can't forget about our extra electron. So again, I'm just going to kind of put it off to the side here, and then I can add it in when I'm ready, or when I know where I want to put it. Okay, so let's go ahead and start drawing some bonds in. So I'm noticing that we could draw some bonds here, here, and here, maybe. Okay, so let's go ahead and erase those, and we'll draw in our lines for our bonds. So we got 2 electrons here, 2 electrons here, and 2 electrons here. Okay, so let's check. Did that work? So let's look at our nitrogen. Our nitrogen, we have 2 here, right? And then we have 2 here and 2 here. So 2, 4, 6, and then 2 here. So that's 8 total on our nitrogen. So nitrogen's like, cool, I'm happy, right? We wanted that full octet. What about our oxygens? So let's take a look at this guy over here. How many does he have around him? Yeah, he only has 2, 4, 6, 7 right now. He needs another one. How are we going to do that? Well, we do have that extra electron, right? So let's go ahead and maybe add that in just like we did last time. And again, I'm going to show it as a light blue just so we know that that's our extra electron. Okay. All right, so that oxygen's happy now, right? Because it has 2, 4, 6, 8 electrons around it. Okay, what about those other 2? What are we going to do with those? Okay, to understand what we can do after this, because I'm a little bit stumped, we have to know what a double bond is, okay, because there's a double bond in this. So let's put a star here, and then we'll know to come back to it. And let's go down here and learn about double and triple bonds. So far I've shown you only Lewis structures that have single bonds. What's a single bond? Well, a single bond is when you only have one line and that depicts 2 electrons. A double bond occurs when atoms are sharing 2 pairs of electrons. 2 pairs. So remember, here's 1 pair, right? That's 2 electrons in a single bond. A double bond is just what it sounds like. It's 2 of those single bonds. 2 pairs of electrons, right? Each line has 2, so there's 2e here and 2 electrons here. So how many electrons total are in a double bond? Yeah, 4. 4 electrons total. Okay, so how would I do 2e, 4e? And then what about a triple bond? Yeah, that has 6 electrons. Yeah, because you got 2 here in that first line, 2 in that second, and 2 in that third. So we got a total of 6. Okay, so a double bond occurs when atoms share 2 pairs of electrons. And they form when there are not enough electrons to complete octets. Okay, so if you just formed a single bond here between that carbon and that oxygen on the left here, you wouldn't have enough electrons around, just even, I mean, both of them, but this oxygen is just looking there. We wouldn't have enough electrons around that oxygen unless we formed this double bond. Okay. And then for triple bonds, those occur when atoms share 3 pairs of electrons, and they form when there aren't enough electrons to complete octets. So again, if we have this nitrogen over here, and we just did like a single bond or a double bond, we'd find that we didn't have enough electrons to complete those octets around nitrogen. But if we look at these now, and let's just zoom in a little bit. So if we look at this now, looking just at nitrogen, and I'm drawing my circle around it, how many electrons do we have there? We have that lone pair, which is 2 electrons, and then we have 2, 4, and 6, right? Because each of those lines is 2 electrons, and we have 3 of them, so that's 6 total electrons. So that nitrogen has 8 electrons around it, which is perfect. That's exactly what it wants. Okay? All right. So while the octet rule is very useful, there are some exceptions. So like we've seen this several times, hydrogen only requires 2 electrons to form a noble gas arrangement, right? It just wants to be like helium. Like helium. Okay? And then there are some nonmetals, for instance, phosphorus, sulfur, chlorine, bromine, and iodine, that can form compounds with 10 or 12 valence electrons. So I haven't really talked about it, but if usually an atom doesn't want any more than 8. Most atoms don't, okay? Well, most of the atoms that we're going to be dealing with in this class don't want more than 8 electrons. They just want 8. They want to be like a noble gas. But yeah, there are some exceptions. So just to be aware of them, I'm not ever going to like trick you. So yeah, so don't worry too much about that. But just so you're aware. So the sulfur atom over here in the middle, you'll see that it's bonded to 6 fluorines. And there are 12 valence electrons, or another way of saying that is 6 bonds to the sulfur atom. So looking just at the sulfur, right, we can draw our circle around that sulfur to show which ones, how many electrons. And we have 1, 2, 3, 4, 5, 6 lines drawn. And each line is 2 electrons. So we have 2, 4, 6, 8, 10, 12 total electrons. Okay, you'll notice though that each fluorine only has 8, which is what we would expect. Our fluorines are not one of these exceptions here. So we don't notice them having extra bonds. It's just that sulfur that likes to kind of mess us up. Also, you will see sometimes you'll see boron actually only really likes to form 3 bonds. So this boron, looking around this boron, how many electrons are there? We have 2, 4, and 6. 6 electrons on that boron. So that's actually less than the octet rule. Okay, so that's an exception there. And boron is one of those ones that does often like to form 3 bonds. You'll notice that your chlorines still have the number you would expect here. So that's got 8. Okay, but just some exceptions to be aware of. But again, I'm never gonna like try to trick you. Okay, I'll usually, if I ever have you drawing anything like these, I'll like give you a hint on your test, like hint, sulfur can have more than 8 valence electrons or something like that. Okay, so let's do a couple practice problems. Let's do the first one together, and then we'll do the second one. I'll have you do the second one on your own. Okay, so SO3. So let's do that. I guess we have enough room here. Yeah, let's just do the first one here. So we'll do SO3 on this page. So we got SO3. So, okay, we have sulfur, 1 sulfur atom bonded to 3 oxygens. So again, I'm just writing out which atoms I have and kind of arranging them how I think they might be arranged. And I can change it later if I need to. So I'm putting sulfur in the middle and I've got my 3 oxygens around it. So let's go ahead and populate with electrons. So, and I don't see any charge here to be aware of. So we just have the electrons that we would normally expect. So sulfur, what's sulfur in? Sulfur is in group 6. So it has 1, 2, 3, 4, 5, and I don't know, 6 electrons. Oxygen's also in group 6. So it has 1, 2, 3, 4, I don't know, 5, 6, 5, and 6. All right, so let's zoom in just a little bit here, because give ourselves a little more so we can see a little better. Okay, so I'm noticing, let's see, none of these are happy. None of them have their octet, right? So let's try to fix that. So let's go ahead and maybe we can form a bond here. I'm seeing, oops, I was trying to highlight there. I'm seeing that can be a bond, right? This could also be a bond. This could be a bond here. Okay, and would that make sulfur happy? I think it would. So let's go ahead and draw our bonds. So I'm going to erase these 2 and make this a bond. I'm going to erase these 2 and make that a bond. And then I'm going to erase these 2 and make that a bond. All right. And then, let's see, that sulfur now has 3 electrons around it. All right, so we have 3 electrons around that sulfur and then 3 bonds. So let's count for that sulfur. We've got 2 here, 4, and 6, and then we have 7, 8, and 9. Okay, so that might be too many, but sulfur is, again, one of those weird ones that could maybe have more than 8, so we're just going to kind of keep it in our back pocket for now, just as something we're aware of. Let's just double check our oxygens. So how many electrons does this oxygen have around it right now? 2, 4, 6, and 7. Okay, so that oxygen's not happy. What if I steal, oops, what if I steal this electron that's on this sulfur? Because it looks like it's an extra. So maybe he'll share and give it to oxygen. So let's go ahead and put that over here. Okay, so now that oxygen looks like it's happy, right? It has those 8 electrons. So I'm going to put a check mark there because I don't want to change it. It looks like it's happy. Sulfur, 2, 4, 6, 8. Okay, now sulfur has 8 around it. So what if we scoot this and put it here? And then we can check. So I just rearranged those so that I had a lone pair. So now let's check these other oxygens. So let's see. This oxygen, how many electrons? Ooh, so just like before, these 2 oxygens are still not happy, right? They only each have 7. So what can we do? Well, what if we make one of these a double bond, right? We just learned that that was allowed. So what if we take this electron right here on that sulfur and we move it right here, and then we can move this electron over here, and then we can form a bond. So let's get rid of this one. We just moved it, and we're moving this one as well. We're going to move it there, and now let's draw our bond. Okay. All right, so now looking at this oxygen, are we happy here? We have 2, 4, right? That double bond, each of those lines has 2 electrons, and we have 2 lines, so that's 4 total. And then we have 4 here. Yeah, so that's a total of 8. So that oxygen is now happy. And then let me get rid of that yellow behind there because I don't want that to be confusing. Okay, so that oxygen is happy. Okay, great. And then this is like a small thing, but it's bothering me. So anytime you have these lone pairs, see how they're kind of next to each other, but there's this whole blank space over here. So because they've electrons, if they're too close together, they're going to push away. So we're going to actually, let's just that. And that's to show that they kind of will, they're repulsed by each other, okay? Because they both have those negative charges. All right, so now we just have one more electron that's not happy. Our sulfur, it has that extra electron here, which, I mean, I haven't seen a Lewis structure that has just one electron hanging out. They're usually in pairs or bonded. So what if we move this electron here? And then sulfur is happy, and so is oxygen. The other ones we already checked have 8 electrons. And then what about sulfur? Yeah, sulfur has 2, 4, 6, and 8. Yeah, sulfur's happy too. So in this case, sulfur didn't even have to have more than 8 valence electrons or more than an octet. So that's great. And this would be your Lewis structure for SO3. Kind of cool. Well, minus the check marks. And let's actually clean it up so that it's all one color. Make it blue. Yeah, then we better make this blue too. Oh gosh, okay. Oh my gosh, sorry. Can't my computer read my mind? Okay, let's try B now. B, let's just do over here. So B is CO, C and O. Okay, so this one's gonna be a little bit trickier. All right, so there's no central atom because there's just 2 of them, so I guess we'll just do it like this, I don't know. And then carbon is in group 4A, so it has how many valence electrons? Yeah, 4. 1, 2, 3, 4, just like that. Oxygen has 6. 1, 2, 3, 4, I don't know, 5 and 6. All right, okay. How are we going to do this? Let's zoom in just a little bit. And this is kind of bothering me that that's right there. Okay, are either of these atoms happy right now? No, they're not. So what are we going to do? Well, I'm seeing that we can form some bonds here. So what if we could bond these two, right? So what happens when we do that? Let's get rid of those and put in our bond. All right. So now that carbon has what? 1, 2, 3, 4, 5. 5. That's not quite enough, right? We need 3 more. And then our oxygen has 1, 2, 3, 4, 5, 6, 7. So oxygen's not happy either. Okay, well, we saw that this double bond worked kind of well. So what if we do a double bond? So let's bond these 2 electrons. So I'm just going to draw that here. Okay. Did that work? Well, it looks like our oxygen's happy, right? We've got 2, 4, right? 2, 4, 6, 8. Okay, so that's great. But what about our carbon? How many electrons are on carbon? Well, we've got 2, 4, 5, 6. That's not enough. What are we gonna do? Sorry, I don't know why that little text mark is there. Okay, hopefully, no, shoot, sorry. Okay, so what are we going to do? How are we going to fix this? What if we try a triple bond? Could we do that, do you think? Okay, let's try it. So, I don't know, I'm seeing that these could bond, right? So let's just try it. Let's try a triple bond. We haven't done it yet, so let's see. So, go ahead and draw those two there. So, how many electrons are around, well, let's go, how many electrons are in this triple bond right now? Yeah, 6 electrons in that triple bond. Why? Because 2, 4, and 6. There's 2 on each of that lines. We got 3 lines, so that's 6 total. Okay. Well, now oxygen has way too many, right? It has 6 from the triple bond, and then 2, that's 8. It has 9 now, so that's not right. Is oxygen one of the ones that we said could have extra, more than an octet? No, oxygen's not one of the exceptions. So oxygen is not going to want that extra electron. What about carbon? Carbon's got 1 here and then 6 here, so it needs another electron. What if we move this electron over here and it can just hang out next to carbon? Would that work? Yeah, let's try it. So we'll put that other electron here. Remember, I'm not just adding an electron out of nowhere. I moved it. And that's okay. All right, so carbon now has the 2 here from the lone pair and the 6 from the triple bond. Okay. Oxygen has 2 from its lone pair and 6 here. And this looks good. Yeah. Our first triple bond. So let me just go ahead and clean this up. We'll make it blue. And this is what the Lewis structure for our CO molecule looks like. What's CO? Yeah, carbon monoxide. Yeah, you just drew carbon monoxide. Pretty fun. All right, so I just put a box around those just because I'm confident in my answers, but I guess we'll check anyways. So let's look here. Do we get it right? S in the middle. Oh, yeah, so this is a perfect example. So I put my double bond in a different spot. Does it matter? No, it doesn't actually matter. As long as you have the correct number of double bonds in there and everything has like the correct octet and the electrons are shown. You could have had the triple bond, the double bond there. You could have had it where I put it, or you could have had it even there. You just need to make sure you have the right number of double bonds. Notice that we only have 1. Okay, and then for our CO, looks like we did it. Yeah. Okay, so a lot of it is really just like trial and error, okay? I think I'm going to cut this there and we'll come back for this next section.